Welcome to 5.2, Verifying Trigonometric Identities. We are going to work on example 4, where we have 1 plus cosine x over 1 minus cosine x minus 1 minus cosine x over 1 plus cosine x, and we're trying to get to see that that equals 4 cotangent x times cosecant x. Clearly the left-hand side is more complicated, so we will start with that. Notice that there are two different expressions here on the left-hand side and only one expression on the right-hand side. Therefore, the first thing we need to do is combine these two expressions. Well, in order to add or subtract two rational expressions, they need to have the same denominator. However, this is 1 minus cosine x and that's 1 plus cosine x. So the least common denominator for the left-hand side is going to be 1 plus cosine x times 1 minus cosine x. Therefore, we're going to need to multiply the top and bottom of the left expression by 1 plus cosine x, because we're trying to get this expression to have both 1 plus cosine x and 1 minus cosine x on the bottom of both. Well, we already have 1 minus cosine x on the bottom, so we need to multiply top and bottom by the 1 plus cosine x here. So we're going to get 1 plus cosine x, and then we already have a 1 plus cosine x. So I just rewrote the colors. So the purple is what we already had, whereas the red is we're multiplying the top and the bottom by the same expression, 1 plus cosine x. Now on the right expression here, we already have a 1 plus cosine x on the bottom. I'll copy the top as well. So since we want both 1 plus cosine x and a 1 minus cosine x, we're going to now multiply top and bottom by 1 minus cosine x. So we can see here that now our denominator has a 1 plus cosine x and a 1 minus cosine x on both of them. 1 plus cosine x, 1 minus cosine x. Now we need to multiply this out. So we're going to do that rather carefully. So really the 1 has to distribute, then the cosine will distribute. So we get 1 plus cosine x plus cosine x plus cosine squared x on the top, and on the bottom 1 plus cosine x minus cosine x minus cosine squared x. Then on the left side, and what you might notice right away here on the bottom, the cosines will cancel out, but not on the top. So multiplying the top and the bottom of this expression here. Okay, so the bottom of each of these will simplify to 1 minus cosine squared x. So since they both have the same denominator, we can write them as one expression with one denominator. And now with the top, I'm going to simplify the left, so I get 1 plus 2 cosine x plus cosine squared x. So I'm just combining these two middle terms here. But on the right, I'm going to take an extra step and distribute the negative. So I'm going to distribute this negative to each of these terms here. So I get a minus 1, a plus cosine x, plus another cosine x, and a minus cosine squared x. So now we are ready to go ahead and simplify the top. So we can combine any like terms or let anything cancel out. So what we might notice here is that our 1's cancel out. Our cosine, we have 2 cosine and then another 2. So we end up with 4 cosine x, and then our cosine squared x's cancel out since one is positive and one is negative. So we only are left with a 4 cosine x up top, and we'll just copy that 1 minus cosine squared x on the bottom. So now is when we have to take a peek at this right-hand side. So we have a 4, which is interesting because we have our 4, so that's good, but we don't have any fractions here. So oftentimes when we have something on the bottom, like this 1 minus cosine squared x on the bottom, but we're trying to get rid of fractions, we want to put this into one term. So that's where our Pythagorean identities come in. So let's hop over here. We have sine squared x plus cosine squared x equals 1. And we're trying to get 1 minus cosine squared x. So let's go ahead and pull the cosine squared over. We're going to subtract cosine squared x from both sides. And we end up with sine squared x is 1 minus cosine squared x. Ha! There we have it. So now we can replace this 1 minus cosine squared x with sine squared x. So over here, over on the left, we end up with 4 cosine x over sine squared x. We're just replacing the 1 minus cosine squared x with sine squared x. Well, it's looking a little better, but we still have this cotangent and cosecant. I don't know how we're going to get those. So let's see, can we in fact go ahead and split that up? So let's see, we have our 4. Now we need a cotangent. So if we need a cotangent, we need a cosine x over sine x. So let's see, if we had a cosine x over sine x, there's a cosine x, there's a sine x. So there's one thing left that we did not yet use up. So we've used the 4. We've written this as cosine x over sine x. But this was sine squared x. So we still have another sine x on the bottom. And let's take a peek. That is in fact our cosecant x. So we in fact, we're able to take this expression here, pull it apart into the cotangent and into the cosecant, and we end up with 4 cotangent x cosecant x. Now, I want you to be very clear here. This last step will very much depend on the right-hand side. So there are actually different ways you could divide it up. And so you have to look here and kind of force it to split these up in a way that actually gives you the right-hand side. So now we are done because we took the left-hand side, we found a common denominator, we simplified. Then once we simplified, we realized we still had adding and subtracting on the bottom. So we used the Pythagorean identity to rewrite the bottom as just one term. And then this is where it seems a little artificial. Then we split up this one term into different factors, but looking at the right-hand side. This is where we really have to be thinking about that right-hand side and how we're going to divide it up. And that gave us that 4 cotangent x cosecant x. So we showed that the left-hand side was actually equal to the right-hand side. Example 5. In this situation, both sides are actually rather complicated. However, the left-hand side has adding and subtracting on the top and on the bottom. So I'm going to go ahead and again start with that left-hand side. There are a few different options for this one. Because the right-hand side only has sines and cosines, I'm going to start by making everything in terms of sines and cosines. So I'll write cotangent x as cosine x over sine x and cosecant x as 1 over sine x. Well, that's just handy because all of our fractions have a denominator of sine x. If we multiply the top and the bottom of the larger fraction by sine x, it will in essence cancel all of the denominators out. So that leaves us with cosine x minus 1 over cosine x plus 1. Whenever we have a situation where we have a 1 plus or minus cosine x in the bottom or 1 plus or minus sine x in the bottom, one strategy is to multiply by the conjugate. It is common to rewrite the cosine x plus 1 as 1 plus cosine x, and this is just so that it's more evident that when I go to multiply top and bottom by the conjugate, I'm going to multiply top and bottom by 1 minus cosine x. This right here is just because it's addition, I could flip it. I left the top the same. So now when I go to multiply this out, I'm going to be careful with my signs on the top. So I get a cosine x, and then I get a negative cosine squared x. Then I multiply the 1 to get a negative 1 and a positive cosine x. On the bottom, I will get a 1 minus cosine x, so here, and then plus cosine x, and then a minus cosine squared x. Anytime we have this a plus b, a minus b, we do expect the middle terms to cancel. So feel free to skip straight to 1 minus cosine squared x. That's totally fine. Now, simplifying the top, we'll start with a negative cosine squared x. I'm just going in order. The cosine x, we'll get 2 of those, so plus 2 cosine x, and then minus 1. On the bottom, the cosine x's cancel because 1 is positive and 1 is negative, and we are left with 1 minus cosine squared x. Okay. So now we look and we have a lot of the same types of things going on. So we have a 2 cosine x, we have a cosine squared x, and we have this minus 1. But notice on the top, everything is a different sign. So what we could do is we could pull out a negative from the top. So if we factor out a negative, then we get cosine squared x minus 2 cosine x plus 1. And the reason why I'm doing that is so that all the signs will match. Now for the bottom. This should start to look familiar. As soon as we see 1 minus cosine squared x, we're thinking, Pythagorean identity. Sine squared x plus cosine squared x equals 1. Subtract the cosine squared x over, so we get sine squared x is 1 minus cosine squared x. Haha. So our bottom, because we had 1 minus cosine squared, we can now replace it with sine squared. Okay. So the last step is just a little bit of rewriting. So here, this negative, remember with a fraction, a negative could be on the top, out front, or on the bottom. Really what we need to do is we need to look over to our right-hand side. The negative is with the sine squared, so we can just rewrite it as negative sine squared x. Now the top, so this negative is taken care of because we moved it down. Now the top we just need to reorder. If we're careful about the signs, reordering is not a problem. So we put the 1 first, it's positive. Then minus 2 cosine x is next, it's negative. And then the cosine squared is now positive, so we put the plus cosine squared x, and we found ourselves at the right-hand side. So this equals the right-hand side. These last 2 examples are definitely challenging because not only are they requiring some trig using your identities, but it also is requiring some pretty heavy algebra. So hang in there, and really just lots of practice is key. But one thing to note is when you're doing this type of example, when you get to a point where you have just a 1 plus or minus cosine or a 1 plus or minus sine, that's when you want to multiply top and bottom by the conjugate. And that oftentimes helps get you in the right direction. So I hope you enjoyed this video, and see you next time.